All right, this lecture is going to be going over chapter 5, which is learning about how to identify good measurement. As always, please read your textbook. Okay, so this chapter overview, first we're going to talk about different ways to measure variables. So we already talked about what variables are, but there are a number of different ways we can measure variables. Then we're going to talk about the reliability of measurement, so how to figure out if our measurements are reliable. So are the scores that we're getting when we're measuring something consistent? Then talk about validity, so trying to figure out if the way we're measuring something is actually measuring what we're trying to measure, right? So is that a valid measurement for whatever it is that we're trying to look at? And then finally, interpreting construct validity evidence. Okay, so obviously we've already talked about variables, right? It is something that has at least 2 levels, right? It can vary. And a variable can be expressed 2 ways, which again, we've already talked about. We can have conceptual variables or operational variables. So conceptual variables, like we talked about last week, are variables, ideas that are kind of in the clouds. So it's kind of a theoretical idea. Operational variables is something that we can actually measure or manipulate, right? That is something that is, more tangible. Okay, so we talked about this last week again, but conceptual variables are operationalized to become an operational variable, and the way we can do that depends on what we're really trying to look at. So there's a number of different ways we can operationalize a conceptual variable. And we talked about there's good ways we might be able to operationalize something compared to other ways that might not be as effective operationalizations. Okay, so for example, if we're trying to look at happiness, so our conceptual definition, conceptual idea of happiness is a subjective well-being. So you just want to see, how are people doing? Are they happy? And that's, you can look at someone's own perception of his or her well-being, and that's a conceptual idea, right? We can't actually measure that very well, so we need to operationalize it. So one way we could do that is asking participants to respond to 5 items that ask about their life satisfaction, and there's a 7-point scale, right? So 1 is strongly disagree and 7 is strongly agree. So I'm sure you've all done questionnaires like this before, but there is a psychologist, Ed Diener at University of Illinois. He's known as Dr. Happiness. He spent his whole career studying happiness, and this way to ask people about their subjective well-being, this scale, is one way that he does that. Okay, so that's one way to operationalize happiness. So if we look at this is kind of what that would look like. So this is only 5 questions. I don't remember how many I just said, but there'd be a number of questions, all that deal with a subjective well-being, and then it's a self-report questionnaire. So you would read through, and in most ways, my life is close to ideal, and then strongly disagree to strongly agree, right? So you're rating each of these things that are all asking about the same thing, but just in a different way to report how happy you are, right? So that's one way we can operationalize the variable, happiness, okay? Obviously, there's more than one way, so we could also ask a question like this. So imagine a ladder with steps numbered from 0 at the bottom, 10 at the top. The top of the ladder represents the best possible life for you, and the bottom represents the worst possible life for you. Which step of the ladder would you say you personally stand at this time? Okay, so this is asking the same thing, right? Subjective well-being, how happy are you, life satisfaction, how you feeling just in general about life, but just a different way to operationalize it. They're both getting at the same question, right? But they're both doing it in a different way. Okay, so we're trying to figure out how we can figure out which way to operationalize is the best. Okay, that's what this chapter is really about. So this is just different variables and 2 ways to operationalize. So gratitude towards a relationship partner, asking people if you appreciate it, or watching couples interact and seeing how many times they thank each other, right? That's showing gratitude. So 2 different ways, a self-report and an observational measure. So that's obviously there's a number of different ways we could operationalize that. But something like gender, you might think, well, there's not very many ways to operationalize that, but there really is. So you could ask people on, again, a self-report survey, what gender they identify as, or you could operationalize by doing a phone interview, and then the researcher, just based off the person's voice, how they sound, they can guess what gender that person identifies with. So 2 ways to operationalize it. Obviously, one's probably going to be a bit more accurate, a bit more reliable and valid than the other. Okay, so you can do that with any sort of variable you're looking at. If you want to read those, you can, but there's many ways to operationalize every variable, but we really want to focus on trying to figure out, if the way we're operationalizing something is good or not. Okay, but before we get to that, we want to look at 3 common types of measures. Okay, so in the previous slide, I talked a little bit about it. So you can measure things different ways, obviously, and there's 3 main types of ways you could, measure something. So the first is a self-report measure, which would be something like a survey or, an exam kind of thing, where people are recording answers to questions about themselves in a questionnaire or an interview. Okay, so if you want to know something, you want to know how wealthy someone is, what gender they are, how happy they are, you literally go to the person and ask them, right? So that'd be a self-report measure. Second type of way you can measure something is an observational measure, also known as a behavioral measure. So that would be like the example of being on a phone call and just listening to the voice and observing someone's voice and then basing your conclusion of what gender they are off of your observation. You could also do this by like physically looking at someone, observing their appearance, how they dress, basing their gender off of that. You could even operationalize it and saying, okay, what color are they wearing? Are they wearing feminine or masculine color, and basing your gender assignment off of that. So again, many ways to operationalize it. And those all would be examples of observational measures because you're recording just something that you're observing, right? So the researcher themselves are looking at someone or listening to someone and basing observations off of that. Okay, and then the last type is a physiological measure, which we haven't talked about yet, but a physiological measure is measuring something by recording biological data. So you're also, looking at the person, observing them, but you're recording something that's a little bit more specific than just, what you see. So this could be something like brain activity, so doing an EEG or an fMRI, recording different levels of activity in different areas of the brain, when the patient's watching something or the participant, I don't know, any sort of brain activity. You can measure hormonal levels, heart rate, right? So physiological things, bodily things, they're not just like seeing happen, but that you're actually using some sort of tool to measure, okay? So those are the 3 different types of measures. Again, for each variable, we can use any of these to try to operationalize it. And there's going to be many ways that we can do these different things to measure different things that are still trying to get at the same variable, if that makes sense. So for example, for happiness, we can do a self-report measure, which we've already talked about, could be something like a survey or questionnaire. So both examples we gave for happiness could be examples of self-reports, right? You have that 5 questions with a strongly disagree to strongly agree, that scale, that's a self-report. Or even asking a simple question, where on the ladder of life are you at? That would also be a self-report, right? Observational measure, something behavioral. We could watch someone and then measure how frequently they smile or how frequently they laugh. Having that be a, you know, that be a measure of how happy someone is. There's other things we could observe too. We could say maybe people who are happy dress in brighter clothes. So look at observing, what they wear, observing how often they talk to other people. Maybe, we think that being social is a sign of happiness. And if you're sad, you're not as likely to interact with other people, right? All of those would be observational measures. Or a physiological measure, we could look at, oops, there's another one example here. Look at emoji use in texts even, right? People who use more emojis maybe would be happier. I don't know. And then a physiological measure, we could look at EEGs, right? Look at brain waves. Maybe we think that people who are happier are going to have more of a certain type of brain activity going on. We could look at different saliva, right? Hormones or neurotransmitter levels. There's a number of different brain scans we can do to look at different concentrations of, let's say, dopamine or serotonin in the brain. So use different physiological measures to determine someone's happiness. Okay, so obviously for measuring one simple thing, happiness, there's going to be a number of different ways we can do that. Okay, we could put any variable here. We could put stress, self-report, ask how stressed you are. For behavioral, watch for signs of stress, maybe clenching someone's jaw or sighing a lot means someone's stressed. And physiological, measure cortisol levels in the saliva, right? So no matter what type of variable you're looking at, there's a number of different ways you can measure for that variable. Okay, and that's all different ways to operationalize that variable. Okay, so we already know variables have at least 2 levels, sometimes more, but you need at minimum 2 levels for each variable. And there's 2 different scales or types of variables that we can have. And these hopefully you've heard of before. We can have categorical variables, also known as nominal variables. So the levels of these variables are going to be distinct categories. So for example, we could have species as a categorical variable, right? So we could have rhesus macaque, bonobo, chimpanzee, right? Each level of the variable is a distinct category. So genders, you have male or female, right? We could have, if they're a student, high school student or college student, hair color, blonde, brunette, black hair, whatever, nationality, right? You get the idea. So a categorical variable, you're putting people into different categories. Okay, so you're grouping based on whatever. Quantitative variables are variables that have numbers associated with them. So your height, right? You're so tall. Your weight, your age is a quantitative variable. Your scale of subjective well-being, if you're measuring, strongly disagree to strongly agree, that's a number that we're measuring. Okay, so if the measurement's in some sort of number, it's quantitative. If you're in a group just using words to describe someone, that's a categorical variable. Okay, hopefully that's pretty straightforward. I'm sure you've heard these if you're in any science class, but we're going to get a little deeper now. So quantitative variables, when we're looking at numbers, there's going to be 3 different types of quantitative variables. Okay, so 3 types of quantitative variables. We have an ordinal scale, interval scale, and a ratio scale. So anytime you see scale, you know it's going to be quantitative because a scale, right? If you have a counting scale in your first grade classroom or whatever grade you start to count, I don't know, you have, the scale on the wall from 0 to 100, right? So you learn that scale. Okay, so there's different scales that mean different things, right? But they're all going to be quantitative, all going to use numbers. So the first is ordinal scale, which is just showing that there's going to be a ranked order. Okay, So if we're ranking something, that means there's going to be a first place, second place, third place, so on and so forth. So we could say like top 10 selling books, right? So number 1 is the best, 10 is the 10th best, okay? The intervals in the scale are unequal, which means that there's not like a distinct amount between 1 and 2, right? The interval between number 1 and number 2 is not necessarily, okay, 5% of people like number 1 better than number 2, and then 5% to number 3, 5%. That's not like that. It's just the best, second best, third best, so on and so forth. So maybe you have people vote for, number 1 through 5. If 99% of people vote for number 1, then obviously 2, 3, 4, and 5 is not going to have equal number of people, voting second most, third most, and so on. Hopefully that makes sense. Okay, so that's an ordinal scale. We have also an interval scale. The numerals represent equal distances between levels, right? So now between 1 and 2, it's the same as between 2 and 3. But there is no true 0 in an interval scale. So for example, IQ score, your happiness, body temperature. So in all of those, 0 doesn't actually mean 0. Okay, so if you rate a happiness scale and you have a scale of 0 is strongly disagree, 10 is strongly agree. If you rate everything at a 0, it doesn't necessarily mean 0 happiness. It's just on that scale you had the lowest amount. Okay, so hopefully that makes sense. And then ratio scales, again, scale, you have numbers. The numbers here are going to have equal intervals. So again, same distance between 1, 2, 3, and so on. But there is a true 0. So height, exam scores, all of those things in a ratio scale, 0 means 0. So on an exam score, if you get a 0, that means you got nothing, right? It's or your height. If you're 0 inches tall, then you're not there. Okay, so ratio scales have a true 0, interval scales do not. Okay, so to sum it up again, we have 2 main types of variables: categorical, which you have your categories, such as this stuff. Quantitative, you have numbers. Okay, and under quantitative, you have your 3 different types of scales. Okay. So these are just some examples of different variables that we're looking at. So if we're looking at the degree of pupil dilation in a person's eye, measuring it in millimeters. I don't know if I should tell you the answer, if I should pause the video and try to figure out which type of variables this are. So if they're quantitative or categorical, and then if they are quantitative, if they're ratio, ordinal, or interval. So I'm going to give you a minute to do that. Pause the video and try it, and then I'll just go through and tell you. Okay. Hopefully you pause the video. I don't know. So the first one is going to be quantitative because you're measuring a number, and it's going to be ratio. Number of books a person owns, quantitative again, ratio, right? Because 0 means 0. There's 0 books. Book sales rank on Amazon, again, quantitative but ordinal, right? You're ranking the best to worst. Language a person speaks would be categorical. Pant size would be quantitative and would be interval because 0 doesn't mean 0, right? If you have the size 0 waist, you still have a size, right? It just happens to be the number 0. And then nationality, blah, 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 would be categorical. Okay, so you need to be able to do this for the quiz, definitely, and for the exam. All right, so that's all we're talking about variables. So now moving on to how we can test construct validity, right? So last week we talked about the different types of validity. Construct validity is important because we're figuring out how well we operationalized. Okay, so the way we can test how well we operationalize something, if this measure of happiness, is that actually measuring happiness? Is this a good way to test that? there's two different things that we need to look at. So the first is reliability, which is looking at how consistent our results are. And we'll talk about how to measure that in a second. And then the second is validity. So that's actually checking to see if the operationalization is measuring what it's supposed to measure. Okay, so reliable, so let's say we're doing that scale testing the well-being. Okay, if it's reliable, then for every participant, it should measure the same, right? That measure should be consistent. If it's valid, that means that that measure is actually measuring happiness and is a valid way to measure it. Okay, so let's start with reliability. So there's three ways to test it. We can test with free test reliability, inter-rater reliability, and internal reliability. Okay, so retest reliability is looking at if you give someone that questionnaire one time and you give it to them again, so you're doing a retest, are the scores going to be consistent? Okay, so this is an example here. Okay, so take the happiness test again after 5 minutes. If you get the same score as you did the first time, then that's a reliable measure, right? So retest, you are giving the test more than once to make sure that every time it's given, the same score is achieved. This is really important for stable constructs, so things that aren't likely to change. So something like intelligence or someone's personality, that's not going to change in a blink of an eye. Something like testing for someone's emotions, so seeing how happy they are. Maybe you test it once and then something happens in that 5 minutes, their boyfriend breaks up with them. Obviously, they're not going to get the same score 5 minutes later, hopefully, right? So this is something that we're using to test something that's a stable construct, unless we're giving the tests like one right after each other. Okay, inter-rater reliability. We're looking for consistent scores no matter who is doing the measuring. Okay, so if I gave you a test and then Dr. Proust gave you that same test, you should get the same score, right? So who's administering the test, who's administering their questionnaire, who's doing the observational study, who's doing the physiological data collection, no matter who's doing the test, you should get the same score every time. Okay, that's inter-rater reliability. Then we have internal reliability, which also known as internal consistency. So the participant provides a consistent pattern of responses regardless of how the researcher has phrased the question. Okay, so for testing happiness, and we have the 5 questions, they're set up to measure happiness the same way. The participant should give similar responses, get similar scores on all of those questions, right? Internally, we want our questions to be asking the same thing accurately. Okay, hopefully this makes sense. So we can look at this, figure out if something's reliable. The first way is we can use scatter plots. So this example, people used to think that smarter people had larger heads because there's more of a brain, whatever. So a larger head circumference was meant they were more intelligent, right? So to operationalize intelligence, they were measuring head circumference. Okay, so for this example, whoever is doing the measurements did a test retest. So in this case, they measured once and then measured again. Okay, so you can see for Taylor, the first time they got a 50 centimeter, second time they got 52. Kendra, 61, 59, etc., etc. Okay, so if there's good retest reliability here, you want the points on this graph to follow the slope of the line very well, right? Because if you have 75 on the first one, 75 on the second one, which is what you would want them to be exactly the same. If you have good reliability, then you would follow the line exactly. Okay, so these are bunched pretty close to the line. So this is showing that the retest, the measurement number 1 and measurement number 2 were accurate. So your retest reliability would be good. Okay, you could do the same thing with inter-rater reliability. So you could have, say, I measure it the first time, and then I have my friend Bill measure it the second time. Okay, so we have two different measurers if we're doing inter-rater. And it would be the same thing. You want my measurements and Bill, did I say Bill? Bill's measurements to be the same, or pretty close to the same for each person. Okay, and we can visualize that with the scatter plot. That's all the scatter plot is doing. So this is showing the same thing, inter-rater reliability. So this is, what is this even looking at? So there's two independent observers, Matt and Mark. They are rating 10 children on a scale of 1 to 10, indicating how happy they look. So we have Mark's ratings down here and Matt's ratings here. And then the children, again, has Mark's ratings plotted on one axis, Mark's on the other. Okay, so if all the children's ratings are close to the line, that means that Matt and Mark have good inter-rater reliability, right? So Jay was the unhappiest that Mark thought, and Matt also thought Jay looked the most unhappy. Okay, so you want both measurements to be similar in order to have good inter-rater reliability. If you get data that looks like this, then that's not going to be good inter-rater reliability. It's going to be bad, right? Because Mark thought Jackie looked very happy, but Peter thought Jackie did not look happy, right? So we want Jackie to be right at the same level for both of them, but it wasn't. So you can see the scatter plot here is really distributed. There's dots all over the place. So this would not be good inter-rater reliability. Okay, so scatter plots are a really good way to easily measure how good the reliability is. Okay, oftentimes we don't just want to rely on interpreting a scatter plot, so we can do some statistics to determine the reliability between either a test-retest or inter-rater. So we can use what's called the correlation coefficient, which is R. And it's a number that describes how close the dots on a scatter plot are to the line drawn through them. So it's doing the same thing, looking at that line that we draw through the scatter plot, but just giving us a numerical way to interpret it to make sure that our results are reliable. So there's two parts of a correlation coefficient. First, it can either be a positive or negative number based on the direction of the slope. If we have a positive slope, obviously it's going to be positive, right? So positive, this one would be positive. This slope would be negative, right, going down. And this one would be no slope at all. So it starts with either positive or negative, and then it tells you the strength of the correlation. Okay, so it's from either -1 to +1. Okay, if it's weak, it's going to be close to 0. So something like this would have an R value, see it says here, of 0.01. So that's very close to 0, saying that the slope here probably is pretty flat, which means that there's not good reliability. Something like this, what does it say? R equals 0.93. So that's really close to 1. So this is really good reliability. Okay, this one 0.57, not as good, but better than this one. This one would be a negative 0.59. So again, not as good as something as strong as this, but still more reliable than whatever is going on here. Okay, so correlation coefficient just gives us numerical data to explain the reliability. So normally in class we do this. But so this, first of all, would be a positive slope, right? So it's not going to be C. And then our options 0.3, so that would be bad reliability, and this would be kind of medium, and this would be strong. So I'd probably say this would be a 0.78, kind of close to 1. This is a pretty strong association between X and Y, pretty strong correlation. So for that, I would choose B. Hopefully that makes sense. All right. So this is just a whole bunch of text. I'm not going to read through the whole thing, just explaining, right? Test-retest reliability we talked about, Iterator reliability, talks about the R's, what we want them to be at for each. We talked about those. We have not talked about internal reliability yet, so that's what we're going to talk about next. So internal reliability, again, I briefly mentioned it, is when we want participants to give consistent pattern of answers no matter how the question is phrased. So again, if we have, the 5 questions asking about happiness, for all of the questions, no matter how they're phrased, how it's asked, we want people to respond that they're the same amount of happy, right? The way we can look at this is using Cronbach's alpha, also known as coefficient alpha, to test for internal reliability. Okay, so the R value was for the test-retest and iterator reliability. Cronbach's alpha is for internal reliability. Okay, if it's 0.7 or above, that means it's reliable. This is not a statistics class, so we're not going to go through this, but you collect the data from a large sample of participants, compute them all together, all the possible correlations between all of the items to get Cronbach's alpha. Okay, so you should just know Cronbach's alpha is for internal reliability, different than internal validity. Okay, don't get these confused. So if you're reading a paper, oftentimes you'll see that they tell you the different reliabilities. So again, coefficient or Cronbach's alpha is showing you the internal reliability. So again, we want it to be above 0.7. So these would have good internal reliabilities. And then this is showing our test-retest reliability, so the R value. Again, we want something close to 1 for here. Okay? We might see something like this. On the quiz, I might give you a coefficient or test-retest, these different values, and you have to tell me if it seems like a reliable, number or not. Okay, so that's reliability, making sure that we're consistent no matter who's measuring it, no matter if we measure it 5 times in a row, it stays consistent, and making sure that the way our questions are phrased or the way that our observations are done, that no matter how something, is asked or done, that the participants are going to get the same answer every time. Okay, so that's reliability. Second part of this chapter, or third, whatever, is looking at validity, right? Making sure our measurement is measuring what it's supposed to. Okay, so when that last example that said, someone's head size can show their intelligence, is that a really valid way to measure intelligence, right? It might be reliable. Maybe every time we measure someone's head, no matter who measures it, it's the same size every time. But is that actually related to someone's intelligence? Okay, so validity is looking at if our operationalization, the way we operationalize something, is it good or not? Your book has this chart. Again, this is all looking at construct validity, how well something's operationalized. Reliability is what we just talked about, and now we're talking about validity, which is all of this stuff over here. Okay, so if you get confused, I know there's a lot of different validities, a lot of reliabilities that look kind of similar, so this is a good way to kind of map that stuff out. Okay, so let's talk about some validity. Okay, and again, all of this is looking at construct validity, how well something's operationalized. Okay, so there's 2 subjective ways to assess validity. So we have face validity and content validity. Again, subjective, which is just based on like personal feelings, your tastes, or your opinion. Okay, so face validity is if it looks like what you want to measure, which sounds pretty straightforward. But for this, you would probably consult an expert. So someone who knows about happiness, bring them your scale and say, does this look like a reasonable way to determine if someone's happy or not? Okay. So obviously subjective, because the expert is just basing the validity of that on his own opinion. So take it for what it is. The other way we can subjectively assess validity is looking at content validity. And that's making sure that the measure contains all parts of the theory that you say it should contain. Okay, so let's see, if we're trying to test intelligence. Intelligence, we come up with a list of, what is intelligence? Well, it's being able to reason, plan, problem solve, learn quickly, comprehend complex ideas, yada, yada, yada. So we come up with what our idea of what intelligence encompasses, and then making sure that the way we operationalize our test of intelligence includes things that test all of these. Okay, so same thing for happiness. What does happiness include? Includes being healthy, maybe, having good social relationships. It includes getting exercise, whatever you think, I don't know. What do you think happiness is? And then coming up with a way to test happiness that looks at all of those things. That's looking at content validity. Okay, and again, these are all subjective because what you think happiness includes might be different from what someone else thinks happiness includes. Okay, so obviously it's a good place to start to assess validity, but we want to get into more empirical ways, so things that are actually tested, and most psychological scientists prefer to rely on empirical assessments over just subjective judgments. Okay, so there are ways we can do this. This is known as criterion validity. This is evaluating whether the measure under consideration is associated with concrete behavioral outcomes that it should be associated with. Okay, so we can have correlational evidence or known group evidence. Okay, so I'll just show you an example to explain this here. So if we're doing criterion validity, again, making sure that what we're measuring is associated with that concrete behavioral evidence that we have. So this, we're looking at correlational ways to do that. Okay, so this, a business, whatever, wants to determine which aptitude test to give potential candidates for their job, right? So everyone who applies for the job takes this test, and they want to see if it's a good way to determine if they're going to be a good salesperson. Okay, so what we could do is have people who work at the company take this test A and also take test B, and then compare their scores to the sales figures in thousands of dollars. So how many thousands of sales that they get each year or whatever. Okay, so we already know this data from the people who work at the company, and we're just correlating that with their scores on this aptitude test. So you can see in this one, aptitude test A, there's a really good correlation between their score on this test and how many sales they get. Okay, so the lower score on the test means they have lower sales, so they might not be a good candidate. If they get a higher score, like Arena on the test, they have way higher sales than everyone else, so they would be the best candidates. Okay, so this test would be a valid way of assessing if they're a good candidate for that job, right? It's actually testing what we want it to test. Whereas aptitude test B score, same thing, so you have your scores on the test, and you're comparing it to the sales that each person gets. But here we don't have that nice, we don't have that nice correlation, right? So some people with high scores don't do very good in sales. Some people with low scores do better in sales than these high people, right? So this is not a good, valid way to determine if people are going to be good at sales or not. Okay, so hopefully this makes sense. So it's criterion validity, basing our validity off of known criteria that we have, and this one is correlational evidence. Okay, this is especially important for self-report measures, and this, an example that might hit kind of close to home for you guys, taking the ACT or SAT to get into college. A lot of colleges base their, admission of students off of these scores. but is that really going to be correlated with student success, right? Do people who get a high ACT always do better in college? I would assume, based on just teaching for a while, that these test measures aren't necessarily a good way to predict success in college. Okay, this is using correlational evidence. We can also use something known as the known groups paradigm, where we look at criterion validity with things that we already know is going to happen. So if whatever we're looking at is a good measure, then we know levels of something should be higher in a specific group that we already expect it to be. So for example, public speaking. We know public speaking causes anxiety, right? Just a natural thing. And we're trying to figure out, okay, we want to use cortisol to measure anxiety. How do we know that that's a good measure of anxiety? So what we do is we measure cortisol levels in people that we already know should have high anxiety, right? So if you're public speaking, your anxiety should be high. So if cortisol is a good measure, then in those individuals, they should have high cortisol levels. Okay, it's a known group. We know anxiety is going to be high. So if we're trying to use cortisol to measure anxiety, then this would be a good way to test it. Same thing for the lie detector tests, looking at skin conductance or heart rate. Is that a good measure? We could take a lie detector test and people lie. That's how we determine, if they're lying or not. Okay, so using a known groups paradigm. So examples your book gave, definition first, I suppose. So you want to see if scores on the measure can discriminate between two or more groups whose behavior is already confirmed. Okay, so for example, this is using the Beck's depression inventory. So it's a scale used to measure how depressed someone is, right? Or maybe a potential measure. We don't know if it's really good or not. So to determine if this is a valid way to measure depression, we get a group of people who aren't depressed and a group of people who are depressed, okay, based on some psychiatrist's evaluation. Have them take this BDI, this test that we want to see if it's valid or not, and compare their scores. We know depressed people obviously are already depressed, so if this is actually measuring depression, they should score higher than the group that's not depressed. See how that works? Hopefully. You can't ask questions, so hopefully. So you could do that with just two groups, depressed or not depressed. We could also do it a little more advanced and have no depression, mild, moderate, and severe depression. To separate it out even further, so it's not just looking at basic depressed or not, but seeing if it can actually evaluate the severity of someone's depression. So if you have no depression, your score should be lower, mild will be a bit higher, moderate a bit higher, and severe should be the highest, right? So Beck's depression inventory is actually a valid way to measure depression. It's been used for a while now. And a similar test, subjective well-being scores. These are just the scores from a bunch of different studies looking at the subjective well-being of different people. So M is the group mean, right? So subjective well-being is the lowest based on this in Veteran Affairs hospital patients. Male prison inmates is pretty low. French Canadian college students have a pretty high subjective well-being. Okay, so it's kind of just interesting to look at. All right, getting close to the end here. Two more validities we can look at, convergent validity and discriminant or divergent validity. Okay, so we looked at some validities already, but if we are doing a test, we want to make sure that a measure correlates with other measures of the same construction. Okay, so if we're looking at the Beck's depression inventory and this, which is the Center of Epidemiologic Studies depression scale, another depression scale, they're both measuring depression. If you look at one depression scale And the other depression scale, if they're both measuring depression, they have the same construct, then you should get the similar scores for both of them. So if I take two different depression scales, I should get the same results for both if they're valid. Okay, that's convergent validity. Discriminant validity is kind of the opposite. So a measure should correlate less strongly with measures of different constructs. Okay, so there must be differences. So Beck's depression inventory, again, measuring depression, compare that to physical health problems. You should not see a correlation there, right? Because we don't want a depression inventory to actually be measuring just other health problems. Maybe, people who have health problems aren't as happy as people without health problems. But if it's a depression inventory scale, people with health problems, shouldn't be getting diagnosed with depression, right? Maybe they aren't as happy overall, but they shouldn't be getting diagnosed. So we don't want the depression scale to be diagnosing other things like physical health problems. Okay. For a lot of developmental disorders, symptoms can overlap. So when you're screening for autism, oftentimes there is a, a language delay. So you want to make sure there's discriminant validity for things for autism. You don't want to, wrongly diagnose someone with a language delay as having autism just because they have that one symptom. You want to make sure that, a test for autism isn't just looking at one of the symptoms, it's looking at all of the symptoms, if that makes sense. Okay. And if you were to look at this, you want the R values that we've talked about earlier in convergent validity to be close to 1, right? We want these to be related. Discriminant validity, we want the R value to be low. Something like 0.16 would be a good R value for discriminant validity. Okay. Hopefully this makes sense. And just the last slide here. What's the difference really between reliability and validity? So validity of a measure obviously is not the same as reliability. We can have something that's super reliable. Every time we measure someone's head circumference, we get the same measure, but that's not necessarily a valid measure of intelligence, right? So what's most important first is that our measurement is valid, that what we're looking at, what we're measuring is actually measuring, the variable that we're trying to look at. Okay, reliability is just looking at how well the measure correlates with itself. Validity is looking at how well the measure is associated with something else. So reliability is necessary to have a good study, but it's not sufficient, right? We need the measure to be valid more than we need it to be reliable, but we also need it to be reliable. Hopefully that makes sense. Okay, if you have any questions, please let me know. Use the question forum on EduCat, or send me an email if you prefer to do that, or office hours, whatever works best for you. All right, thanks guys. Let me know if you have questions.